Hello everyone, and in today's episode I will be continuing the Golang. I think it's part 5 of my Golang StarCraft II data processing library that is required for my research. And in this episode I will be trying to implement the multiprocessing in Golang, which is data parallelism. I want to have data parallel computation of my files. And we are here once again in the whiteboard, where I will show you what is the program flow. So let's say we have some files. We have a directory of files. So we have replays. We have multiple replays, and currently it's done by processing or replay in replays, let's say. So this would be in for each, and this is done on a single core, single thread, if I remember correctly. And so this will be working substantially slower than, let's say, a multiprocessing approach where we have replays and we are splitting the replays into chunks, and we are performing processing on subset of replays. So let's say here we have 10,000, right? So let's say if we do 5 chunks, it would be nice to perform computation on 2000 each here. Yep, so in this case we are speeding up our computation because this processing 2000 files by one thread will be faster if we do this for each thread that we have available, for each core that we have on our CPU. So let's say I have 12 cores, so it's 24 logical cores, and so it just speeds things up. I don't want to go into the technical detail because I am not familiar with it. I would have to research that a little more, but let's just say we want to process chunks, so it goes a little faster. So in this case, I already drafted a solution, which now it's incorrect because I have already drafted a solution which is currently incorrect, and it's incorrect because I would be performing parallel computation for each of the replays and not for the chunks. So I need to rewrite that in order for this to work correctly. And then later on I also need to introduce logging and introduce some other stuff which will be utility when it comes to packaging the process. In order to perform everything correctly, I have defined a pipeline wrapper which is quite similar to multiprocessing pipeline, but let's say that for every chunk I will create a new thread which will be processing a list of files, and then later on for each of the files I will be performing the standard pipeline of processing pipeline for a given file. So this needs to be renamed in order to fit what's happening more. So I will be renaming the functions for sure. I will be making some of them private, which in Golang is done by either capitalizing the first letter or making it small. For example, if I call this one multiprocessing pipeline with a small letter, this will mean that it's private, it's not visible from other files which are not in the same package, if I remember that right. And so let me try and speed it up for you guys. I'll be on passing the stuff from the arguments here into the multi. Currently I am dissecting the main function, which was not multiprocessing based. It was not executing my program in parallel, specifically in a data parallel mode, let's call it that. And so I need to get this buffer and writer in order to write into the archives, into the zip archives, and later on save those archives into the drive. And for that specific reason I need to move zip utils from the main package into the data processing package. And this is not something that will break this program functionality. I think it will even be better in case of just moving these files around into specific places, so that later on, when the program is ready, on the top level we'll have only the main Go function and a nice architecture which splits the respective code parts based on their response. It's another day because working on this is quite a long project, and currently I am just verifying the main function and seeing what do I need to move into the data processing pipeline within the multiprocessing chunk pipeline function. And in order to do that I need to get the file utils from the package main and move them to file utils in the package data pros, or maybe even create a whole separate package for that matter. So bear with me and we will be switching some code. So I've just moved all of the utils files to a separate package and I will be making the changes right now. So hopefully the architecture of this solution will be clear, and people, when they will be using this, they'll just read the file names, they will read the directory structure, and they will have a vague idea. Right now I'm cleaning up the main function, the main file, because all of the logic was moved into the data processing pipeline, and main file will not hold this information here. The main file will only call other functions which will have their own responsibility. The main file will only be the entry point for my program. So that I think that's the best way to structure this currently, moving from a little sloppy architecture into something which is more. As you can see, I am renaming some functions because technically this is read or create file instead of create file, because as you can see I am trying to open the file, and if it doesn't exist, if it fails, then I'm creating it if it doesn't exist, right? And then I'm reading bytes from it if it exists, because JSON unmarshal requires me, I think, to pass in the byte values, right? Yes, and so, well, that's just the thing. I'm refactoring most of the code, so bear with me, and pretty soon we'll have this project. Okay, so it seems that I have solved the problem. I have cleaned up the main file. As you can see, it's much more clear. There is not as much indentation as there was before. We have as much as 2 levels when we use if statements, and apart from that we have the rest of the logic that was moved into the data processing pipeline, into the multiprocessing chunk pipeline, which will be used by the pipeline wrapper and will be multiprocessing the files. It will be data parallel algorithm that will deal with chunks of files instead of one file at a time, which will speed up the program execution considerably. And I hope that this will be something which will work. So right now let's just commit these changes and solve the rest of the problems that we have outlined here in the terminal later on, because there is much more work to be done within this project. But let's finish this for now and let's just commit that So git status, git add all, git commit, and let's say drafted pipeline wrapper, or rather multi-processing pipeline. Maybe let's just verify for this one to be specifically and exactly the same as we called it in the code. Defined to do. So that's a nice piece of work. Let's push it out. That's a nice piece of work, and I like how this code is coming together. Hopefully when I will be testing that one, there will not be much problems with different files being saved by different workers or different threads or whatever you want to call this. So thank you very much for being with me here right now. And I think this will be all for the part 5. We just drafted a rough idea of multiprocessing in Golang, and I hope you liked it. I hope you will follow me on other social media, and I will see you in the next